Another part of the homework tonight, and what we talked about in class, was solving equations using a reciprocal. So in class, we talked about what a reciprocal is, and we looked at how you would find one. So let's say I had a number, and I wanted to identify its reciprocal. This is also sometimes called the multiplicative inverse. If I had the number 1/2, and I think what number would I multiply it by to get an answer of 1? And we saw that if you multiply it by 2, then I could do, it's like 1/2 times 2, put our 1 down here, that's going to equal 2 over 2, which equals 1 whole. So for a reciprocal, we basically just found we flip the numerator and the denominator. If I had the fraction 2/3, my reciprocal, I flip, is going to be 3 over 2. So if I multiplied those, I would see 2/3 times 3 over 2 gives us 6 over 6, which is the same thing as 1. We also could think about cross-simplifying when we're multiplying, which we looked at yesterday. These would cancel each other out, or both divide to 1. These would cancel each other out and both divide to 1. 1 times 1, 1 times 1. It's all going to equal 1. So anytime you have a number, if you can turn it into an improper fraction, if it's not yet one, then you would just flip the numerator and the denominator and you've identified its reciprocal. Now you can use the reciprocal when you are solving certain kinds of equations, because you know that anytime you multiply by a reciprocal, you'll get an answer of 1. So let's say, for example, we had an equation and we had 2/3 x equals 5. We want to solve for x. We want to find what value is going to make this true. Now, I could divide by 2/3 because I know that this is multiplication here. But I could also think about this as, what can I do using the reciprocal? Now, we identified up here that the reciprocal of 2/3 is 3/2. And if I were to multiply 2/3 by 3/2, that would equal 1. And we want to remember, our goal is always to isolate this variable, to leave this as only a variable on one side of the equation and then a number on the other side. So if I were to multiply the left side of this equation by 3/2, making sure to remember to do the same thing to the right side. 3/2 times 2/3, these are going to cancel each other out. I could multiply them across and get 6 over 6, or I could simply just say, well, these will cancel each other, these will cancel each other, and I would just end up with x on the left side. On the right side, I have to multiply, these are fractions, so I'll turn my 5 into 5 over 1, and then I would have 15/2. 15/2 is the same thing as the mixed number 7 and 1/2. So this would be my final answer. And if I were to put this back in my equation, I would see I would get an answer of 5. Do one more example of this. Let's say I had, 2/5 x equals 1/2. Now I'm going to use the reciprocal again to solve this equation. So I'm going to look for which side is my variable on. It's on the left side. It's being multiplied by 2/5. My goal is to get rid of that 2/5, isolate the variable. So I'm going to have to multiply by something to get rid of it. Now, if I multiply by the reciprocal of 2/5, which I just flip the numerator and denominator, so 5/2 times 2/5, the x is still there. I'm going to do the same thing on the right side, multiply by 5/2. Okay, so all I've done is I've multiplied both sides of the equation by this reciprocal of this number right here. Now these will cancel each other out. They'll give me 10/10 or 1. So I'm just left with 1x, or x, on the left side of my equation. On the right side, I would multiply across. 5 times 1 gives me 5. 2 times 2 gives me 4. So if x equals 5/4, we always want to turn our fraction into a mixed number at the very end of the problem. So I could do 5 divided by 4, or I could just think of how many pieces could I take out. Take out 4 pieces, leave me with 1 left. So we have 1 whole and 1/4 as our answer. So this is one method of solving these kinds of equations. We simply multiply by the reciprocal. That'll cancel out anything next to that x, and then we're just left with the variable and the answer on the other side of the equation.